Good afternoon. I'm Tom O'Neill. I'm the CTO and co-founder of Periscope Data. And today we're going to talk about SQL, Python, and R together. Before we get started, can I see a quick show of hands? Who's already using Python or R in their analysis workflows? Cool, almost everyone. So then as part of this talk, I'm hoping to give you some context as to why you're special. Why now is different than 10 years ago when it comes to the use of Python and R in analysis. And so at Periscope Data, we aspire to build the fastest, most powerful, most flexible platform for professional data teams. We have over 1,000 customers, including Uber and Flexport and New Relic. The average analyst on the platform spends about 20 hours per week doing analysis and sharing that out with their company. Every 24 hours, analysts on our platform generate 300,000 lines of new SQL. Right? It is a prolific platform. A ton of analysis happens every single day. And it's really fun to be a part of that. So the primary interface for Periscope is a dashboard. Right? Most users look at dashboards. It has all your normal chart types, your bars, your lines, your pies, in addition to filters and pivots and drill downs, all the things you'd expect from sort of a finished product of analysis. As the analysts themselves, though, you spend most of your time looking at this screen. Right? This is the editor. This is where you write all that SQL, followed by all that Python in a SQL then Python workflow. And the overall platform for Periscope sort of helps with the whole analyst process, from ingestion from SQL sources like Postgres and MySQL, and SaaS sources like Salesforce, Google Analytics. We store that, we warehouse it for you, and then help you ETL it from that raw data into data models and data sets that can be published out as SQL analysis or Python analysis or drag and drop, so the rest of your company can be effective with that data. And so today is about Python. It's about that middle part of the process. And so I think in order to understand why Python is special today, why R is special today in the context of analysis, I want to paint a picture of the data team maturity curve. Like, we've worked with well over 1,000 data teams. And so you can see how it goes from just SQL to moving to Python to moving to sort of advanced machine learning as we learn to predict the future. Then we'll talk about the trade-offs between SQL and Python. And at the end, we'll do some live coding in the product to show you what the workflow can look like when you use SQL for what it's good for and Python for what it's good for. So starting off with, where did this come from? Like, why are data teams special now? Why is it different now? We have to start at the beginning, or at least actually in the 70s. So databases were invented in the 70s. One of the first was a database called Ingress. That is a direct ancestor of Microsoft SQL Server and Sybase. If you've worked with Postgres, that's short for Post-Ingress, which is an alternative sort of database after Ingress. And the important part of databases in the 70s is that this is when we could start asking computers to do our jobs for us. Right? And then fast forward a decade, business intelligence is invented, or at least Gartner coins the term business intelligence. And this is special because the databases up to this point, one of their core use cases is sales data. Right? They're not very powerful, they're not very strong yet, but they store sales data. And we've been asking the same questions of sales for hundreds of years, for centuries. Right? The East India Company wanted to segment their sales by geo, by rep, by product. Right? We're still doing that. That is still classic business intelligence. And so in the 80s, we start doing that with computers. Fast forward 20 years. We now have 20 years of experience modeling that sales data. The internet has been invented. Now e-commerce is a thing. Digital demand is a thing. So we can include marketing in that early database technology. And Tableau comes on the scene. And this is really special. Right? This is the first time data is really democratized for the whole business. Because those data models that we have been building for the past 20 years are now self-serve and drag drop. Right? Everyone at the company, every business department can drag and drop their sales and marketing data and figure out what's going on. But then things change again 1 decade later. Right? Somewhere in the early 2010s, the price of compute gets dramatically cheaper. The price of storage goes to near zero. Right? If you look at your S3 bill relative to everything else, it's pretty much zero. You have a petabyte of data on S3. That's 1,000,000,000 billion bytes. It's 1,000,000 gigabytes. It's about 10 grand a month to store that, which is nothing compared to the system that generates it and the systems that process it. And so now that data is free, right? Storage is free, we start logging everything. And this is really important because it paints the path towards why Python becomes important later on. Storing everything means that we're no longer just storing sales and marketing data. we're storing IoT sensor data, every plane and train and ship around the world. We're recording its location, all of its statistics, real-time text message data, event streams, every click and swipe and interaction with every product and website and mobile app and video game. It's all recorded, right? And this is new kinds of data, and it's extreme volumes of data that is much, much harder to model than the classic sales and marketing data, right? Kimball models are no longer obvious to apply to these challenges, these data sets. And that breaks drag and drop, right? The era of democratized data is at risk because we can't drag and drop, how do you drag and drop lifetime value calculations segmented by certain demographics if you've never asked those questions before, right? How do you answer which arm to run in a multi-bandit scenario without being able to model the data ahead of time? It gets really hard, and so data teams come to the rescue, right? This gentleman is Leon. He runs my data team. When we hired him, it took him a couple weeks to basically solve our classic BI problems. We can segment our marketing and sales data no problem now. And it's different because he doesn't stop there, right? We've asked our data people to come out of sort of the back office of IT and partner with business units like they haven't before, right? He solves classic BI, and now we can start asking questions about our product, about our users. For us, for example, we want to connect the ROI of marketing campaigns not just to which generate leads, but which generate customers who upgrade 6 months later. Right? That's a hard question. If you're a video game company, you might want to know how many tokens to put in the treasure chest at the end of level 4 to maximize lifetime value of each gamer demographic. Right? You can't drag and drop that, but he can do the analysis. Right? He can write the SQL, he can write the Python, he can do the advanced statistics to figure out how to answer that question. And so comparing what new data teams do to classic data teams, the old school data teams are a collection of specialists, right? You've got your DBAs worrying about the warehouse, trying to keep it up. You've got your SQL engineers implementing specs for how to make data models work, right? You get a spec from a BI architect. What data models do you need? And then you implement that, and you hand the data model back to the BI architect, who then makes the dashboards. And none of these people are involved in the business, right? None of these people are partnering with the sales team, not partnering with marketing, they're not partnering with product. And that's why the new data team is different, right? Modern data teams aren't a collection of specialists, they are a team of generalists, right? Because everything is easier now, right? Managing an on-prem Vertica deployment, really hard. Spinning up a Redshift or a Snowflake takes 10 minutes, right? That's just easier. Building your own ETL pipeline used to be really hard. Now you can use dbt and Airflow and a few things like that. Super easy to make ETL work. And of course, now that all those pieces are easy and we have these generalists, we look to them to answer questions we didn't know we could ask. Right? We can ask about tokens and treasure chests. We can ask about lifetime value of different customer cohorts. We're not blocked on requiring data models in order to supply drag and drop to the whole organization. That brings us to the maturity model for data teams. So we've seen well over 1,000 data teams. We started plotting them where they fit, where are they in their journey. Not all data teams are in the same path, and that's OK, but they're all moving in this direction. And it starts with business reporting, right? This is where you have different sources of truth for different departments. It's Salesforce reports for sales data, it's Marketo reports for marketing data, it's Mixpanel for your product data. Trying to answer how many leads did we get is really hard because Salesforce and Marketo will disagree. That's just the nature of the game. And classic BI came to sort of solve that conundrum. This is where you finally have a single source of truth. It can't answer most questions, but it can answer many questions. And you have an authority on how many leads there are and how to get to the root of that answer. But the next category, where it's ad hoc analysis and insights, this is where it gets fun, right? It's not Shark Week every week, but it's pretty good. Because now you can answer questions that you didn't know you had. You can look to the data team and say, hey, I thought up a new question this morning. It's not modeled. I don't know where the data is, but help me figure it out. Right? This is where Python starts to takes place. This is where you start doing statistics on your data and not just group and counts. As you fast forward, the data team starts scaling across the business. Right? Instead of having a couple analysts, now you have a centralized data team. Right? They handle the best practices, the core infrastructure, the career ladder of data people across the company, and you embed analysts in sales and marketing and product elsewhere because you want specialists in those departments who can go deep on what does it mean to really be an opportunity, right? How are we defining it this week? How do we account for all the weird changes sales ops makes over the past 2 years, recategorizing how leads work? And how do we keep our historical analysis accurate? And this is sort of the goal we're all aiming for, right? Can we predict the future? Can we use our data not just to look at what happened and suggest changes, but look at what happened, know what will happen, and then act on that? Companies in this category sort of transcend their industry and become data companies in a very special way, right? They masquerade as some other kind of company, but at their root, they're a data company. Uber, for example, is a data company masquerading as ride-sharing. Airbnb is a data company masquerading as room rentals. These are new kinds of companies, right? Data is such a part of their culture. They are different from the industry in which they participate. And that's pretty cool. So as we look at this curve, I want to give you a framework to figure out where you are and how to move forward in this process. And so when it comes to business reporting, do you have different tools for different departments? Right? Are you looking for different truths in different places? Are you trying to glue those truths together in Google Excel or Microsoft Excel? When you graduate to business intelligence, now you're starting to have a single source of truth. Right? You're starting to agree on definitions. There's a person whose job it is to disambiguate when data disagrees. And the ad hoc part, now you're starting to really blend the data. You're not just saying, this is the right sales number, this is the right marketing number, but this is how the whole funnel works. And we can ask questions of that funnel in ways we couldn't before this time. Up until maybe 10 years ago, most companies stopped here. This was business intelligence. This is the best we could do. Right? We just didn't have the technology to run it. We didn't have the data collected to answer those questions. But now we do, because we're collecting all this new kinds of data, and we can answer new kinds of questions. Going beyond that, then you start looking at the org structure of the data team. Right? Are you using, do you have analysts in the right places in your organization? You probably have multiple warehouses. You're working on a lake already. And you're starting to use Python and R in very real ways. Not just to do a regression, but let's start doing light machine learning. Let's start doing light predictions. And to get all the way at the end, now the data team has a seat at the table. Right? You have a chief data officer. You have a VP of data. And you don't just have them. They're on the leadership team, and people listen. Right? It's really important to have that data leader and have people listen to the data leader and want to ask questions of that data leader. Right? This is how you transform the culture of your business from what it was into becoming a data company. Not just data-driven, but a data company. And so I'm curious from the folks in this room, who is at this middle bucket or further? Who's got the ad hoc analysis going on? OK, very few people, 1 or 2 people. This is good, right? Now we have a map of sort of where to go and what's next, and how to graduate from classic BI into this next world, this more advanced version that we're doing. In terms of the technology involved, it's all SQL all the time, the more basic the situation is. Right? You're just grouping and counting the data you have. As you get more advanced in your data team, as you mature as an organization, then you're you're joining data from different data sources. You're bringing in statistics libraries like from R and Python. And eventually you're doing real machine learning, trying to predict the future for your department or for the whole company. So let's talk about sort of the trade-offs between when to use SQL and when to use Python, now that we know that we want to use Python in the workflow. This is how I think about it. I think about SQL as a relatively blunt instrument that's really, really good at heavy lifting. Python and R, much more specialized. If you want to do something in Python, there is at least one library for that. There's probably multiple. Getting your team to choose one library and stick with it is a fun challenge we'll leave outside this talk. But you want SQL to do the work, right? If you've got 10 billion rows of data, use SQL to get that into a format that then you can hand off to Python or R to do the polishing, the last transformations. Because this is the ideal workflow, right? You want to run SQL, do the work, right? Get a small data set that you're ready to do some heavy math on, some statistics, hand that off to Python or R, and then share out that analysis. And this is a little bit of a warning against notebooks. Jupyter notebooks are fantastic, but they let you get into trouble, right? You can start with some SQL, then you write some Python, then you realize you need a different library, so you change the Python kernel, Then you go back to SQL to get more data. And then, oh, you really like this R visualization package. So let's use R at the end to visualize it. And that's cool. You've done some cool exploratory analysis. It's ad hoc. You figured out the answer to a question. Then you hand that to engineering. Please implement this. Nah, that is not the future. That is not production quality code. That is not a production workflow that engineering will support. Engineering will be very happy with this, right? You do X, then Y, then Z. And this is important because data teams are becoming more and more like engineering teams. Right? A couple years ago, Git was nice to have. Right? Now it's a requirement. Right? Now you want code reviews, you want pull requests, you want to have release operations like dev and staging and prod. Like, data teams are expected to keep the system working because the whole company is depending on it. Right? Another example of that is pager rotations. Right? It's very rare today, but I would bet within 2 years, most data teams are carrying a pager. Right? Data teams are becoming like software engineering teams. We're learning from them. We're seeing all the things they've developed over the past few decades. We want to be like them because we want the durability, the predictability, the scale that comes with like true software engineering. And a lot of those practices apply to data analysis and data engineering. In real life, the workflow is more like this. Right? You've got SQL. You iterate on your query until it's got the right set of data. You hand that off to Python, iterate there until it's the right shape. Maybe you forgot a column, come back, fix it, go forward again. But the goal is to do this. You want to publish this to the rest of the team. And we'll take a look at this workflow later on in the talk. In terms of why is SQL so good at the heavy lifting, it's because SQL is a simple language. Right? SQL is a highly restricted language in terms of what you can do. If a sufficiently clever query planner, like what Redshift and Snowflake has, can take any SQL query and distribute it to 100 nodes and efficiently stitch the results back together. There is no query planner that can do that for arbitrary Python code. It's just not possible in that way. You can use PySpark, which again, but now you're using a highly restricted API, which is basically the same thing as SQL again. So use SQL for what it's really, really good at, and then hand off to Python for what it's good at, which is the more complex analysis. In terms of the data flow as well, warehouses don't read all the data. And so you can just give them so much more data to process, and they'll handle it as appropriately for your queries. If you ask Python to read a 200-column-wide table of 1 billion rows, it will read every single cell in order to process it. Where a warehouse can read it column by column, it'll read 6 of the 200 columns and only process that, which just makes it so much faster for the heavy lifting. So again, let SQL do what it's good at, and then hand off to Python or R to do what they're good at. And speaking of which, think about pivoting data in SQL. Right? If you're putting case statements inside your aggregations to pivot in SQL, we all have, I know, it's not a super fun time. This is not the ideal workflow for SQL, is nesting all these case statements inside your aggregations. In Python, it's one line, right, to pivot a data set. And so likewise in Python, you want to do a regression or a projection. It's just a couple lines of code. On our blog, we've done SQL for sport. We've done confidence intervals in pure SQL. We've done regressions and projections in core SQL. My favorite is an implementation of the hyperlog cardinality estimator in pure SQL, which is a terrible idea. You should never do this. But we did it to show that we could, to show that SQL could. But it's much better to use a language like Python, use real data structures like hashes and Bloom filters to get that done. These are some of the custom visualizations you can make in R and Python. These are from our community pages where folks have posted a couple dozen lines of Python or R. If you want your line chart to change color as the Y increases, it's super easy. You want a super custom radar chart, you can make it an oval radar chart if you want. That works too. You've got bullet charts with a new axis down the middle. This is all possible in Python. Where if you're using just SQL, you're stuck with whatever the visualization options are of the platform you're using. Because SQL only returns tables. So if you want a very special looking kind of bar chart, either the platform has to support it or you can do it in Python, which is pretty cool. So let's stop looking at sort of pictures of what has been done in the past, and let's do some of this together. I'm going to jump into Periscope. This is Periscope for a pretend video games company. It's a dashboard showing how much money they're making and how many users they've got, their average revenue over time, some maps showing where the users are, and some fuzzy box plots showing lifetime values by platform. And so we're going to start with a blank dashboard. And we're going to make the same chart first in pure SQL, then in SQL plus Python, just to show where the workflow can trade off. And then we'll do things that SQL can't do by leveraging some of the flexibility of Python. And so this is the editor. It starts with SQL up here. So we're going to do a daily revenue chart. So here's our purchases table. And so if we want daily revenue, it's select the date of created at. Typing on stage is super easy. We'll sum the price. Cool. So this is going to give us our dates and our sums. We can easily convert that into a line chart. We've got our line chart down here. And then if we want to segment by platform, that's super easy. We'll just drop in platform and group by that. And now that same line chart is now daily revenue by platform over time. So we'll call this daily revenue. We can save this to our dashboard. Now we're going to do the same thing, but using Python just to show sort of where that works. We'll start with this chart using the same data model, but we'll switch to using Python for the analysis. And so you can use Python 2.7 if that's your jam. I like to use Python 3. R is also available too. We'll add that. And what happens is we'll pass the output of the SQL query to Python as a pandas data frame. So if we ran this just the way it is, we're just passing data frame right through Python. You get the same results back out. What we want to do is plot this, right? And in this particular API, the data format needs to be X, Series 1, Series 2, Series 3, as you do your columns, which is not this format, right? This is X, segment value, and Y. We could pivot this in SQL. That's kind of a pain. Pivoting it in Python is really easy. So you pivot it equals dataframe.pivot. And you say index is going to equal our X value. Our columns that we want to segment out come from platform. So our segment column. And the Y values we're looking for come from the sum, which is our prices. And if we want to look, say, what is going on in pivoted, we can pass that out to our data frame as we run that. So you've got Android, iOS, and web, the values as they pick up, because they don't all start on the first day. And you have all the normal things that you'd want from like a Python environment. If you wanted to print to standard out, pivoted.describe. We'll see, OK, we got Android and iOS and web. We got our means, our medians, our maxes, our statistics coming right out, so we can understand what the shape of this data is. And at this point, this is super easy to plot because we have it in the right format. So add this to the plot. And now we've got daily revenue by platform in Python. Oops. Cool. Conveniently, the data looks the same because it is the same. And so at this point, now we're going to upgrade a bit. Now we're going to do things that SQL can't do. Right? Let's do a regression. Right? No one, like doing the mx plus b in SQL, kind of painful. In Python, it can be as easy as a line, as easy as 1 or 2 lines. In order to do the data points, let's compare the number of times a user has played the game with how much they've spent sort of in their lifetime. So we'll build a couple CTEs. Say with user plays as. Are folks familiar with CTEs, how they work? Yes, yes. Kind of, sort of? OK, it looks like some people are familiar. If you're not, this is a way to make named subqueries that you can query later on. So we'll select, let's see, the user ID and the count. Plays from Periscope views.gameplays by 1. We'll clean up the formatting in a minute. And we'll also make a user spend. This will just be a second CTE that lets us see how much the user has spent over time. User ID, price as total spent from Periscope views.purchases. And we'll take a look at one of the data sets, user plays. We'll format it so it's a little easier to read. And as we run this, you can see we'll get our user ID, the number of times they've played. And what we really want, though, is the join of these two. So we'll select num plays and total spent. From user plays, join user spend, using the common key, which is user ID. And just to make this a little bit faster, we'll limit it to 100. Cool. So now we've got data that we want to correlate. We'll do, just to keep the demo running rapidly, we'll do poor man sampling and just come down to a 1% sample. For user ID mod 100 equals 0. So we'll get 1% of the data back. Now we'll go to Python. At this point, we're going to use Seaborn. This is a super convenient plotting library. It's going to make the next couple charts really, really easy. And so we'll say our plot is going to be sns.jointplot. Joint plot is a type of chart that shows you a scatter plot and also histograms on both sides. So you can take a look at what the shape of your data is, not just as a scatter. Super useful for certain kinds of analysis. And our x value is going to be the number of plays. The y value is going to be total spent. Our data is, of course, our data frame. And joint plot takes a few different options. And so we'll start with a regression chart. And then we'll send that back out. Cool. So now we've got a regression, right? Our Pearson correlation coefficient is quite high at 0.92. This is the kind of thing that's really hard to do with just SQL, and even just Python if the data set's large enough. But by combining them together, say, OK, make my data in the right shape, hand it off to Python to do the math, and visualize it out to the dashboard. Our data is way too heavy, near 0. And so this is where the workflow starts like sort of showing how it gets pretty tight. We'll just say, OK, we want only our top players. So say where num plays, say greater than 150. So we'll get rid of these single play players. Cool. Now we have just our top players working. We go down here, rerun the exact same Python script. And this looks a lot better. Right now we can start to see how the data is clustered. The histograms look a lot healthier. And we can save this out to our dashboard. We'll say this is, oops. This is going to be plays versus spend. Spelling does count. Cool. Just want to show off a little bit more of what Seaborn can do. So instead of making just a scatter chart, it also supports something pretty cool called Hex Spinning. So if you change this to hex, the exact same code from before now gives us a plot showing where the intense areas are of the scatter. Right? Because it's hard to see how points overlap unless you go to hex spinning. I think we've had enough blue charts already, so let's change this to pink. M for pink, just sound it out. And that was a joke. Now we got our pink hex spinning chart, and we can save that to the dashboard. All right, we'll do one more chart in Seaborn. The previous couple charts we segmented by platform. These are not. So let's use Seaborn to segment by platform to see how easy that can be. So we'll clone this again. We don't have platform in our data, so we'll add platform here and group by it, as well as platform here, and of course in our output. This will change our data set from 2 columns to 3. Right, so we've got num plays total spent by platform. We'll go down to our Python and say, instead of a joint plot, we'll use an LM plot, which is a combination of different kinds of plots. It lets you plot multiple things on the same canvas. We still need our x and our y and our data. We no longer need kind or color, but we do need the column to split by, which is going to be platform. And as we run this, you'll see now we've got a scatter for web and Android and iOS, and they're pretty different. Right? You can see how the points they're not all the same distributions. And because we like colors, we can say, hey, change the hue of each chart based on which platform. Cool. We've got platform, an orange one and a green one. We can save this out. And on our dashboard, make this a little bit bigger. Cool. Now we're starting to build up our dashboard. We've got daily revenue by day. We've got a few different scatters of it. We can see how the distributions are different. We've got a few minutes left, so I figure why not do one more chart. We'll reach a little bit, go for a 3D scatter. I think those can be pretty fun. So edit this one. We need a, oops, we'll edit as copy. We need one more data point in order to do X and Y and Z on the scatter. And so we'll add it to our price. We'll say, OK, not just the sum of the price, but the count of num purchases, right? How many times have they purchased? We'll send that to our output as well. Num purchases. And cool. And we'll get rid of Seaborn. We're going to use matplotlib instead. So pyplot as plt. And from the matplotlib toolkits, we will, what's this one called? mplot3d import x's 3d. Right. This is going to let us build a 3D canvas. The boilerplate code for that looks like plot.figure, and then add subplot. And now we get to have some magic numbers from the API docs. Equals 3D. And this is all the boilerplate code. This is how we get to a 3D canvas for our scatter. And the next part is super easy. We just say canvas context scatter. Unlike the Seaborn API, we have to pass in arrays of what values we want. We're going to pass in numplays total spent. Oops, did we not run that? Here, total spent and num purchases. Cool. So our x is going to be numplays. Our y is going to be total spent. And our z is going to be num purchases. Cool. This should give us a scatter plot. Cool, 3D scatter plot. At this point, we can add some labels to it. I'm going to set our x label to be number of plays. And we'll do the same thing for the y and the z. This will be total spent and number of purchases. Run this again. Got some nice labels on our chart. And since we are big fans of segmenting by platform, we'll do that here too. With matplotlib, you have to pass in color codes. You can't pass in a name, and it'll figure it out for you. And so in order to do that, this is the kind of thing where Python, again, shines. We'll say, OK, data frame, extend it by adding a colors column. That's going to equal the platform column. But we're going to replace it with a dictionary. Right? So our Android platform will be, let's say, green. Web will make blue. And iOS we can make red. And we can pass that in as C is df of colors. Uh-oh. Where did I mess up? Does anyone see the error?
Bracket after R in your dictionary.
Yes, thank you. Good job. Cool. Now we've got our 3D scatter plot with colors. And we can save this out to our dashboard. And I think in about, what was that, 15 minutes time, we've made a half dozen charts, different analyses in both SQL and Python, just to show you what's possible when you combine that workflow together. So we'll switch back to just a quick wrap-up. The reminder for your data teams, right? You want to staff generalists. You want to staff folks who are comfortable working on the ETL all the way through to Python and R as they build up statistical models and grow into machine learning. Use SQL for what it's best at, right? Write unit tests, do the heavy lifting, make this your durable sort of layer for ETL. And then use Python and R when it makes sense. Not everything needs Python and R. But when you do use it for light transformations, complex business logic, string munging, visualizations, all the things that it's super good at relative to SQL. So thank you for listening. Again, I'm Tom from Periscope Data. I'm hiring on data and product and engineering teams if you want to move to San Francisco. And happy to take questions now. No questions? All right. Well, thank you very much for coming. That's it.